Okay, lots of fun right here to be had. I am not going to include these in the video. They are for your fun, all right? There you go. We're going to get to something else that's going to be so cool. You're going to love this. Here we go. 4 problems that are very similar. 3 teams played in a round-robin tennis tournament. That means everybody plays everybody. And the results are as follows. Jordan Matthews beat Northmore. These are high schools, by the way. Jordan Matthews beat Northmore. Northmore beat Chatham Central. Jordan Matthews beat Chatham Central. We're going to create a directed vertex edge graph that represents the situation. The arrow should point to the loser. Let's just stop reading and go ahead and just jump right in. How many teams are there? 3. What are they? Jordan Matthews, Northmore, Chatham Central. Doesn't matter where you put them, okay? And then we're going to create a directed. We better have arrows, and the arrow is going to point to the loser. So the one who lost is going to be the one that has the arrow pointing at them, okay? I know that sounds like we're going to hurt somebody's feelings. Not the intent. Let's keep going. Jordan Matthews beat Northmore. So we point from Jordan Matthews to Northmore. I'm not calling Northmore a loser. I am saying that Jordan Matthews beat Northmore, okay? But the one who lost gets the arrow. Don't be picking on Northmore. That's where I went to school. Northmore beat Chatham Central. So we point to Chatham Central. Jordan Matthews beat Chatham Central. Okay, so here is what's about to happen. If possible, find the Hamiltonian path and rank the tennis teams from best to worst. This is a great way to find ranking, but it has to be a directed graph. And I want you to notice this word right here that I will underline in red. Find the Hamiltonian path, not a Hamiltonian path. If we have more than one answer here, then this is not going to work. I think you'll see that as we go. So I'm going to start with the impossible and work my way towards the possible, okay? I want to find the Hamiltonian path. Again, Hamiltonian path, I'm going to cross every vertex exactly once. But now I'm following arrows. So I'm starting impossible. If I start at Chatham Central, I'm stuck. This is not the Hamiltonian path. If we start at Northmore, then we have no choice but to go to Chatham Central, and we have not done the Hamiltonian path. We haven't done a Hamiltonian path at all because we've only touched 2 of the vertices. Let's start at Jordan Matthews. If we start at Jordan Matthews and go to Chatham Central, we never got to Northmore. That's not the Hamiltonian path. Here goes. Jordan Matthews to Northmore to Chatham Central. That is the only way to go and do a path and touch all 3 vertices. So Jordan Matthews to Northmore to Chatham Central. Rank the tennis teams from best to worst. Okay, well, this is going to be pretty straightforward. Jordan Matthews is first place. How do you know? You can kind of look at it and tell. Jordan Matthews won 2 games or 2 matches. Northmore is second place. Chatham Central is third place. Chatham Central lost both games. Northmore won 1, lost 1. There you go. Our Hamiltonian path revealed the ranking. So let's go to one that's a little bigger. 4 students had a rock, paper, scissors tournament. Each student played every other student. That's round robin. That's what that means. Evan beat Bruno. Valeria beat Bruno. Jake beat Bruno. Okay, let's just go ahead and say it. Bruno's going to come in last. Evan beat Valeria. Valeria beat Jake. Evan beat Jake. All right. Create a directed vertex edge graph that represents the situation. Let's just use first letters. Evan, Bruno, Valeria, Jake. There are 4 students, and here they are. And we are always going to point to the one that lost. I'm not going to call them the loser anymore. That just sounds terrible. So let's point to the one that lost. Evan beat Bruno. Valeria beat Bruno. Jake beat Bruno. Poor Bruno. All right. Evan beat Valeria. Valeria beat Jake. Evan beat Jake. If possible, find the Hamiltonian path. If there is more than one path, we can't rank them. Rank the tennis teams from best to worst. That's a typo. My bad. Somebody copied and pasted. Rank the people for students. Rank the students from best to worst. Okay. Good idea is to start with the one that didn't lose. Okay? Evan never lost. There is nobody pointing at Evan. So let's start with Evan. If you don't start with Evan, and let's say you want to start with Valeria, then you can go to Bruno or you can go to Jake and then Bruno, but you'll never get to Evan. Okay? Just saying. No matter how hard you try, you'll never get to Evan. That leaves Evan out. So let's go from Evan. Evan's going to be first. And we have choices. We can go to Valeria, we can go to Jake, we can go to Bruno. But we have to get them all. If we go Jake, we'll never get to Valeria. If we go Bruno, we'll never get to Jake or Valeria. So we have only one choice, and it's to go to Valeria. All right, so again, if I started Evan, and I should, then I could go Bruno, and I'm stuck. I could go Jake and Bruno, and I'm stuck, and I never got to Valeria. So I should go Valeria. Next, if I go to Bruno, I'm stuck and never got Jake. So Jake, Bruno. And again, it makes sense. You look at it. Evan never lost. Bruno never won. Valeria won 2 of them. She doesn't have 2 arrows pointing at her. And Jake won 1 but lost 2. So here's first. I have a hard time drawing the number 1. First, second, third, 4th place. Okay, let's keep moving. Very similar. This one's going to be fun. If it's the one I'm thinking of. Okay, never mind. There are possibilities where, or there are times where it may be a situation that you can't find the directed graph. For example, you might have some arrows and it'd be a little ambiguous about who's first, who's second. Like you might have someone that won 2 games and lost 2, and someone else won 2 and lost 2. In that case, ranking would come from the magnitude of the defeat or the win and that sort of thing. But if we're going just based on this, if we can find the Hamiltonian path, then we've done it. So at this point, you probably have it. You're probably good. But here goes. Brandon, Javier, Victoria, Esther. Same initials as the last one, different order. Brandon beat Javier. Victoria beat Esther. Okay, let's go ahead and stop. Say the obvious. Brandon, Victoria will not be last. Got it? We know that much. Also, when we're starting our Hamiltonian path, we're not going to start with anybody that's being pointed to. We're going to start with either Brandon or Victoria. All right, Esther beat Javier. Okay, I'll go ahead and tell you. We're not, I think Javier is going to lose a lot of these. Victoria beat Javier. Javier is going to be last. If you tried to start with Javier, you'd be stuck and you can't go against the arrows. Esther beat Brandon. We will not start with Brandon. And Brandon beat Victoria. Okay. Ah, yes, this is the one I was hoping it would be. I'd forgotten for a second. Here we go. If possible, find the Hamiltonian path. I think there's more than one. Here we go. I'd love to start with someone that never lost a game. That's not Brandon. That's not Victoria. That's not Esther. Okay? Definitely not Javier. So I can't start with a clear first place. So find the Hamiltonian path. All right, since it's not the Hamiltonian path, I personally am switching to pencil. So I'm going to start with Brandon, and then I'm going to go to Valeria, and then I'm going to go to Esther, and then I'm going to go to Javier. And if I said, okay, fine, do this, but someone else could say, well, I want to start with Valeria, and then I want to go to Esther, and then I want to go to Brandon, and then I want to go to Javier. And then someone else could say, I want to start at Esther, and then I want to go to Brandon. and then Valeria, and then Javier. You have 3 different possibilities of ranking. Clearly Javier is last, but you have 3 possibilities. So there is not, I'm going to write this down, there is not a unique Hamiltonian path. Therefore, we cannot rank the students. Not with this information. Maybe we would need some more information, like how aggressive they were or what faces they made while they were beating each other in rock, paper, scissors. Okay, one more. And based on the information below, we're going to create a directed graph, determine the ranking if it exists, and we're going to have, if you read through this, you're going to have 5 letters, A, B, C, D, and E. So A, B, C, D, and E. And I should have been doing this all along. Let's switch colors for the arrows. B beat D. This is going to take a minute. All right. Don't pick D first if you're going to start your path. E beat B. Don't pick B first either. D beat C. A beat D. A beat E. B beat C. Okay, pause right here. If you were going to start making a path, you'd start with A. A has never lost so far. A beat B. Lucky them. E beat C. E beat D. A beat C. Okay, let's determine the ranking. Let's just go ahead and start listing them. I'm going to have a first place, a second place. I've been writing them horizontally. I'm going to write them vertically this time. A third place, a fourth place, and 5th place. All right, who shall we start with? Nobody that lost. Don't start with anybody that lost. Sometimes you have to start with someone that lost, but in a situation like that, you're going to have multiple answers and there would not be a unique Hamiltonian path. In this case, I'm going to start with A. A is clearly first place. All right, I'm going to go from A somewhere else. If I go to C, I'm stuck. If I go to B, I'd go to D and would then go to C. I can never get to E. So, nope, never got to E. If I go D, nope, I have to go to E next. E came in second. Really looking at this kind of tells you, because A never lost, E lost once, B lost twice, D lost 3 times, C, bless their heart, they never won. There you go. There's your Hamiltonian path. A, E, B, D, C.